All right, the first part of this video, I want to show you guys how to use the velocity sensor, how to hook it up. This would be the first time that you're using it for a lab. So it goes on the opposite end of the track from where the stopper is at. And I want to show you because on the back side, and let me make sure that this is in camera, beautiful. So it's going to connect to this bolt hole right here. And in the boxes, you should find this small gray screw. It is a little bit tricky because sometimes when you push this on, let's see if you can see that. See that screw? It might not be perfectly lined up. So you need to make sure that when you push it in, you get it pushed into that little slot and you'll see it lines up perfectly. You don't want it to be a little off. Once it's lined up correctly, just tighten that guy up. And then the velocity sensor is then on the end of the track. And once this thing is powered on, you should hear it ticking a lot. So probably not have these guys plugged in until all your students are ready to go. All right, lab 2.1 is really an investigation for students for position, speed, and velocity. And using the velocity sensor is going to really help them really experience positive, negatives, position versus speed. And so this will be really good. There's two parts that I wanted to highlight that came out of the accessory box in your SmartTrack thing. It recommends using a level so that you can place it on here, make sure that you're level. Now that's not as important for this particular lab, but that's where you'll find it is in the accessory box. In the same box, you'll also find this. This is what's going to be used for the velocity sensor to easily pick up on its location. It just attaches to the back of your car. You want to make sure that you push in tight because it's not a perfect fit, but it does pretty well and it shouldn't pop off during your experiments. The instructions tell students that they're going to start off in meter mode. That's the bottom left one. As soon as you click this, what we should hear, I don't know if it'll come through on camera, is the sound of the velocity sensor. And you just hear it making noises. So right now, if I'm not moving the car, you'll see that I have a distance. It's telling me I'm at 47, and that kind of checks out with what I see there. And velocity is more or less 0. You'll see it bouncing around between these small numbers, but it's going positive and negative. So that might be a conversation to have with your students is, okay, it's not going to be perfect, but it's giving me a rough estimate. This first part just is having students experiment with moving the piece and making note of their velocity changes. So I see I'm very positive going there. If I stop, I'm back to that 0, fluctuating around 0. If I go backwards, now I'm at a negative number. I can go fast and I'll get a higher number. See, I jumped up to 93 there. Go fast that way, I got negative 100. So students should be able to see, okay, the distance part, very accurate. I'm gonna set this right on the 20. And you can see I'm right there at 20.22, so that is a very accurate measurement of distance. Velocity isn't coming through as quickly, but still not too bad. You can get a general sense of positive velocity, high velocity, negative, and those sorts of things, which is a good experiment. And then students are going to answer a couple questions with that. The second part, this is great if you want your students to both collect and create data tables and graphs. And so for this one, we're actually going to hit the home screen, and it tells the students go to data collection mode. And that should pause our sound for a second. It gives them instructions for the setup. It might be better if you did this part before to have all this fixed. Otherwise, you're going to be jumping around in the middle of the lab to do all this. If these do power down, it does default back to a different setup. So you'll have to leave them on in order to keep this. It tells them to change the samples to 100 and the rate to 20. And what that's going to do is essentially it gives them 5 seconds. They're sampling 20 times per second. 2,800 samples, that's 5 seconds. It says make sure that your first, so SA, whatever you're measuring first, you measure speed. So I'll change that one to speed. And then I'm just over here on the left going to make sure that the rest of them say none and none. We only need to measure speed in centimeters per second. And that's all in the instructions. And there's even a picture to help you or your students, however you're setting that up, to match that up. And then once you hit go, actually don't hit go, it gives the students instructions that they need to come up with a plan as a group for how they're gonna move this, and then you make 3 changes. So I'm gonna go ahead, I'm gonna move forward very slow. I'm going to pause for half a second, and I'm gonna move backwards quicker, and we'll see what that looks like. So let's hit go. Move forward slowly, pause, back. And I think I caught it. Your students might need a couple of goes, but you'll see it stops at 5 seconds. So students are going to have planned that out. They might have to do a couple of trials if they messed up, but now they have a data table where they have their time and they have their speed, and then they can check out the graph. And you can see my graph. Because my speed was really high there at the end, it's kind of morphed my graph, and so you don't really see the changes that went up here. So I'm gonna go ahead and run a second trial with you guys. So let's head to setup, repeat. I'm gonna move forward, I'm gonna pause, and I'll move backwards. So instead of going fast, I just kept a constant speed. That might be a tip that you do with students. And now my graph looks a lot better, right? So my velocity increased as I move forward. You should see now I held it constant here at 0. So my speed had to come back down to 0. And so you get this nice little curve where I was increasing my speed and then decrease my speed until I was not moving. And then I got a negative speed as I started to increase going backwards. You are gonna get this little jumpiness because our velocity sensors aren't perfect, but that's pretty good. And then your students will have some questions to answer regarding that, okay? So that's this setup, the velocity sensor. If you ever have troubles with those, please just let me know. I'd be happy to help.